Hello friends, welcome to CEC live lectures. I am Dr. Pavitra Bharadwaj. I am Associate Professor in the Department of Computer Science in Jesus and Mary College, University of Delhi. So we are continuing with our discussion on computer networks, and today's lecture will also be focused on that. So if you are following the lecture series, so in the last lecture we were talking about client server protocols, which are an important component of how the computer networks are structured. So we had discussed in detail about the hypertext transfer protocol, and we had also discussed about what is the message format, how the request is sent, how the response is received, and how the entire hypertext transfer protocol mechanism works with the underlying layers of the TCP/IP protocol suite. So in the same taking the same topic forward, we are going to talk about other client server protocols in today's lecture. So basically we will be talking about proxy servers in today's discussion, and after that we will be talking about the domain name system. So that is another very interesting area where when we are talking about the World Wide Web, it's very interesting to note how the domain name system is organized and how the domain name system actually transpires when one traverses the world of internet technologies. So when we are talking about hypertext transfer protocol, so here we have a concept of proxy servers. So this is a very commonly known term, proxy servers. We've discussed this. So proxy actually means that this is not real, but it is posing as something else, right? So when we are talking about proxy servers in HTTP, basically we are talking about a computer that will keep copies of responses to recent requests. So the HTTP client, when it sends a request to a proxy server, the proxy server will first check its cache memory. So we've discussed a lot many times about what is cache memory. So it's a temporary area in which some information which is frequently accessed is stored. So whenever the client requires a particular page, so it will send the request to the proxy server, and the proxy server will check its cache. So if the response is not stored in the cache, then the proxy server will send the request to the corresponding web server. And if the response, of course, if the response is found in the cache of the proxy server, then of course the server will return, the proxy server will return. So basically all incoming responses, they are sent to the proxy servers, okay, and they are stored for future requests from other clients also. So proxy server, basic function of the proxy server is to reduce the load on the original server, right? So basically when you have a lot of traffic, where a lot of requests are going to the servers and responses are coming from the server, it increases the latency time, the waiting time increases. So in order to reduce that latency, in order to improve the latency, and in order to decrease the traffic, what we do is that we configure proxy server. So of course the client has to be configured to access the proxy server instead of the target server. So when we have to set up the proxy server settings in the network settings of the computer, so that instead of going directly to the target server, it will first go to the proxy. Only the exchange now will happen through the proxy. It will not be directly from the client to the server, but it will be only through the proxy server. So proxy server now is actually something, it's a server, but it will act as server, and at other times it will act as a client, because when it receives a request from a client for which it has a response, then it will act as a server and it will send the response to the client. But when it is receiving a request from a client for which it does not have a response, there is the page is not found in the cache, then it will act as a client and send a request to the target server. So now when the response from the target server will be received, then it will again act as a server and send the response to the client. So this is very interesting, how the proxy servers behave. They are behaving like both clients and servers at different points in time. Now, where are these located? So normally the proxy servers are located at the client side. This means that there is we can even have a hierarchy of proxy servers which can be used. So you can have a client computer which can be used as a proxy server in a small capacity. So that will store the responses to requests which are often invoked by the client. So in that case, the computer itself becomes a proxy server, or if it is a company, then a proxy server may be installed on the LAN, on the computer LAN, the local area network, to reduce the load going out of and coming into the LAN. And then many internet service providers, they have a large number of customers. So what they do is that so that in order to give a better speed to their customers, they install a proxy server. So what will happen, that with this proxy server, it will reduce the load going out of and coming into the network. So basically this is a technique which is used for balancing the load which is working on the network, which is the traffic on the network, so as to give a better performance in terms of network speed. So if you look at this diagram, it is showing here that how a proxy server has been installed in a particular LAN, and this all the clients are connected to this proxy server, and the network, the local area network, is connected to the internet through the proxy server. So whatever exchange is happening, it is not happening directly, but it is happening through the proxy. Of course, the settings of the client can be changed, and then they may be configured to work without the proxy also, but the main purpose of the proxy here is to control the traffic which is moving into and out of the local area network. Okay, now it's very important. So when we are saying that pages are stored in the cache of the proxy server, and then of course the cache is a small space in which not too many pages can be stored. It's not an infinite or an unlimited kind of storage space. So definitely the one question which comes to the mind is that for how long a page remains in the proxy server, and then after how long will it be deleted or will it be replaced. So for this also different strategies are used for finding a solution, as in for how long the page should be there on the server. So first solution, which is to store the list of sites whose information remains the same for a while. Like for example, if it is a news agency's website, say for example. So now news agency's website would change, a newspaper would change every morning. So this means that the proxy server can get the news early in the morning and it can keep it until the next day. So this kind of page needs to be updated every 24 hours. Otherwise, there is also a field in many of the web pages which keeps information about how long the information would remain valid. So the proxy server will use the information in the header, that is the last modification time of this information, and then after reading this information, that when the page was modified, only then the proxy server can do the calculation and get to know that for how long the information would be valid. So like this the proxy servers will remove the pages from their cache. So it could be either depending upon the type of page which is residing there, or the information in the header field of the page which is there. So this is very interesting how the proxy servers are used extensively over the networks for traffic and flow management. Now another important aspect of HTTP is the security aspect. So we all understand that HTTP per se is not a secure protocol. It does not provide any kind of security, any kind of data privacy to the user. Whatever information is shared on the HTTP, on the web page, on the internet through the HTTP protocol is not secure. So for this, there is another layer which is known as the secure socket layer, SSL, which needs to be run over, right? So HTTP has to be run over with the secure socket layer or the SSL. Now in this case, when there is a secure socket layer which is working on the HTTP, this HTTP is known as HTTPS. So now HTTPS will of course provide all the security aspects, that is confidentiality, authentication and integrity. So all the CIA, the three metrics of information security, that is confidentiality, authentication and data integrity, are all maintained on HTTPS. So therefore, it is always recommended also that only the pages which are HTTPS pages should be considered as secure pages. Now we come to another very interesting aspect, another very interesting type of protocol which is used commonly as a client server protocol on the internet, on the World Wide Web. Now this is the domain name system. So we understand, when we had discussed about the TCP/IP protocol, and we had seen in the IP protocol, in the internet protocol, that every connection is uniquely identified by a number, by a number which is known as the IP address. So every connection on of a host on the internet is identified by a unique address called the IP address, which could be, in the IPv4 and IPv6 we had discussed this. So that is basically a numeric number or an alphanumeric number if we are talking about IPv6. But now, it's also very important that when we have to identify, or when people have to refer to computers, then it is very difficult to remember numbers. It's very difficult to remember the IP addresses, because human beings prefer to use names instead of numeric addresses. So therefore, the internet needs to have a directory system where you can map a name to an address. So this is very much similar, to the telephone directory system, because see, when we had the telephone directory, what happens is that we have a number to name mapping. So every number is saved against a name, and it's easier to remember names than to remember numbers. So the same philosophy has been taken up here also in the case of domain name system. So basically, what is domain name system? So it is basically a directory system where you have a mapping between the IP addresses and the host names, the names by which a computer is recognized vis-a-vis the address or the numeric identity of that computer on the internet. Now, of course, internet is so huge that we cannot have a central directory. We cannot have one single file or one single computer which will hold the entire mapping, because we know that there are millions and trillions of websites, millions and trillions of hosts which need to be identified, right? And also, so this is not going to be an efficient system. Also important aspect is that if that central computer which is holding that kind of mapping, that is the name to number mapping, if that central computer fails, then of course the whole communication network will collapse. So therefore, the system of identifying or mapping the names with the numbers has to be decentralized. It has to be a distributed system. So this distributed system, or this system of having more than one host to store the name number mapping, okay, so this is definitely going to make the system more efficient, right? So this in this system where we are distributing, basically, then the host needs mapping, okay, can contact the closest computer holding the needed information. So this method is used by the domain name system or the DNS. So basically what happens is, if you look at this diagram, it is showing here that TCP/IP protocol, it will use a DNS client and a DNS server to map a name to the address. So if we look here, this is basically a 6-step process. So in the first step, if we see, the host is typing a domain name which goes to the FT, file transfer client. The file transfer client then sends this host name to the DNS client. Now both the file transfer client and the DNS client, these are application layer protocols, these are application layer services which are provided. Now this DNS client then sends a query with the host name to the DNS server to find out the corresponding IP address for the host name that the user has given. The DNS server will look for the mapping in its directory and it will send back the response. So what is the response? The response will be an IP address which is corresponding to the host name. So this response which now reaches the DNS client is actually the IP address, and this DNS client then sends the IP address to the file transfer client. So the file transfer client which requested with the host name gets a response in the form of the IP address. This IP address is then later on chosen by the file transfer server or file transfer client for actually transferring the file. So at the network layer, what will be used will be the IP address. So we are saying that now how does a computer know the address of the DNS server? So when a computer boots, so the address of the DNS server is provided in the settings, in the network settings. So the DNS client will send the message to that DNS server which is already, whose IP address has already been stored in its network setting. So basically in this entire exchange, the DNS server will send the IP address to the DNS client, and with that the IP address, whatever has been received by the DNS client, the file transfer client will actually transfer the file. So basically two connections are required in this setup. The first connection is for mapping the name to an IP address, that is, the request is sent from the DNS client to the DNS server, and the second is for transferring file, that is, the second is that after the IP address is available, then the transfer of file from the file transfer client is going to take place. So basically what is a domain name? Domain name is it's a text by which you can identify the computers, right? So the names, so what is the namespace? Now we are saying that now we are identifying, we are giving a name to every computer. So the name has to be unique because the addresses are also unique. We know that every connection on the internet has a unique address. So therefore every address correspondingly, every name also has to be unique. So the namespace that maps each address to a unique name, it can be organized in two ways. That is, it can be a flat organized namespace, or it can be a hierarchical namespace. Either way, we can organize the namespace. So flat namespace would mean that a name is assigned to an address, that is, a name in this space is a sequence of characters without any structure. So the name may or may not have a common section. So if they do it like this, it has no meaning. Now the main disadvantage of the flat namespace would be that it cannot be used in a large system like the internet, because we need to have something which is decentralized. If you are using a flat name without any structure, you will have to have a central agency which will control the namespace. Only then you can avoid ambiguity and duplication. But we understand that in a system like internet, this will not be possible. This cannot be possible because you have to break the name servers into, you have to divide the work into multiple machines. So in a hierarchical namespace, on the other hand, the name is actually structured, or it is divided into parts. So the first part can define the nature of the organization. The second part can define the name of the organization. The third part can define the departments in the organization, and so on and so forth. So basically it is not one flat name, but it is, it has got different parts, and each part has got its significance. So in a hierarchical structure, unique naming will become very, very easy. And in this case, we can have a centralized authority which will, give or assign the namespaces, and there need not be a centralized authority. Actually, the whole thing will be decentralized. So what we will do is that we will divide the task of assigning names between a central authority and between the individual organizations. So the centralized authority will, assign the part of the name which will define the nature of the organization and the name of the organization. The responsibility for the rest of the name will be given to the organization itself, right? So when we can understand this after, looking at an example. So, the organization can add suffixes or prefixes to the name to define its host or resources. So management does not have to worry that the prefix chosen for a host is taken by another organization, because even if part of the address is same, the whole address will remain different. Because why? Because part of the address has been assigned by a central agency and the rest of the address is being assigned by the organization. So the part which is assigned by the organization may be repeated by other organizations also, but the part which is coming from the centralized agency is definitely going to be unique. So the entire address, the total address will definitely be unique. It will not be repeated, or it will not be duplicated, right? So for example, if we say that there are two organizations, and this we are saying that this can be used for resources also. So if there are two organizations and both of those organizations, they have a computer called the CEC, right? Now the first organization is given a name by the central authority. So the first organization's name is, say, first.com, and the second organization's name is second.com. Right, now each of these organizations will add the name CEC to the name that they have been given by the centralized authority. So now the first computer will be called CEC.first.com and the second computer will be called CEC.second.com. So although the name of the resource, that is CEC, is same in both the cases, but the complete DNS or the complete name is going to be different, because the main name of the organization and the type of the organization which composes the the domain name, they are different. So therefore, like this, we can generate a system of giving unique names. So we will be continuing our discussion on domain names in the next lecture also. Till then, please keep watching CEC. Thank you.